Rahim. Dr. Mohammad Yusuf is here from the Department of Chemistry, Islamic College, Peshawar. Today we will discuss the chapter number 17, which is alkyl halide. Some of the topics in this chapter we have covered, especially in my class B2 section. Today we will continue Grignard reagent. This lecture will cover two things. Number one, what is Grignard reagent? And second, what is the synthetic importance of Grignard reagent? In this lecture, I will say GR, shortly GR. G for Grignard and R for reagent. This Grignard reagent is denoted by RMGX. RMGX, where R is alkyl or aryl group, Mg magnesium, and X is halogen. These compounds, they are known as organometallic. Organometallic means it contains two parts. One is organic and the other is metallic. Organometallic means one part of the compound is organic and the second part is metallic. So what are organometallic compounds? The compound which contain at least one metal carbon bond, that is organic compound which have at least one carbon metal bond. They are known as organometallic. Mostly the metal which may be present in organometallic is lithium, magnesium, zinc, and sodium, and so on. These are the metals which may be present in the organic compound, and hence they are known as organometallic. The second portion is how to name a given organometallic. How to name a given organometallic. So, it's too simple. First, you will name the organic group and followed by the word metal, that is the name of the metal. First, what you will do, you will name the organic group and followed by the name of the metal and followed by some other group which may be present. Here I will give you some example in order to understand how you will name organometallic. Here it is methyl magnesium iodide. It is organic part. This is the name of the metal and this is halogen. So the name is methyl magnesium iodide. In the same way, here, look over here. It is another organometallic compounds, that is CH3O4Bb. This is the organic part. This is the metallic part. So first we will name this one and followed by this one. This is tetramethyl and this is lead. So the name of this compound is tetramethyl lead. Grignard reagent, GR, as I have told you, I will use GR for Grignard reagent. What is Grignard reagent? It is alkyl magnesium halide. It is alkyl magnesium halide. Now this alkyl magnesium halide is synthetically very important compound, and this compound was prepared by Victor Grignard. Victor Grignard. He was a German scientist and he prepared this compound in 1901. And he was awarded Nobel Prize in 1912 for this great breakthrough in organic chemistry. Remember, This organometallic compound, that is alkyl magnesium halide, is synthetically very important reagent. It can be used for the synthesis of a large number of organic compounds. Keep in mind how this compound can be used to prepare alkane. This can be used to prepare alkene. It can be used to prepare alcohol. It can be used to prepare ketones. It can be used to prepare carboxylic acid. Here I have taken only one example, that is that of alkane. Alkane, the rest we will do inshallah in the synthetic application of this Grignard reagent. But just for the sake of understanding what is the importance of this Grignard reagent, I have taken only the example of alkane here. So here, look over here, this is Grignard reagent. Later on, when we discuss the structure of Grignard reagent, you will understand. Here, carbon carry negative charge, magnesium carry positive charge. Here, if it is hydrolyzed with water, then what will happen? This negative will attack on this positive hydrogen. You will get this alkane, and this OH become attached with the magnesium. And in the same way, here alkyl halide will react with this one. So again, this negative will attack here to give RR. RR is alkane. This is alkane, and this is alkane. And you will get MgX2. So only the example of alkane I have discussed over here, and the rest for the preparation of alcohol and for the preparation of carboxylic acid, we will discuss it in the synthetic application of the Grignard reagent. Now, how it is prepared? How Grignard reagent is prepared? Grignard reagent is prepared by the reaction of alkyl halide or aryl halide. Keep in mind, R may be aliphatic or may be aromatic. So if alkyl halide or aryl halide react with magnesium and dry ether, this point should be kept in mind. The ether must always be dry. Means it should not contain any traces of water. Otherwise, water in the solvent will react with alkyl magnesium halide like this one. Here, I have told you here, Grignard reagent is highly reactive toward water. Therefore, you will get alkane and you will not be able to isolate this Grignard reagent. That's why the preparation is always carried out in the presence of dry ether or anhydrous ether. Ether which do not contain any water is called anhydrous ether. So, preparation of Grignard reagent is done when alkyl halide react with magnesium in the presence of dry ether. This will give rise to alkyl magnesium halide. Now, how this reaction takes place, briefly I will discuss here the mechanism. Step number 1, alkyl halide will react with magnesium to generate two free radical, this free radical and this free radical. And in the step number 2 here, these two free radicals, they will combine and this will give rise to Grignard reagent. So this is how Grignard reagent is prepared. So the mechanism is free radical. If you look over here, it is a free radical, it is a free radical. So the mechanism of Grignard reagent preparation is a free radical. We have used ether over here as a solvent. So sometime in exam the question may be asked, what is the role of ether? What is the role or function of ether in the preparation of Grignard reagent? First, it provides an inert medium. Inert medium means as Grignard reagent is highly reactive, this one is highly reactive. Therefore, some inert medium must be used in order to protect the structural integrity of this Grignard reagent. That's why we use ether as an inert medium. Second, this stabilizes Grignard reagent. Look over here. Here, alkyl magnesium halide, magnesium carry positive charge, while oxygen here and here carry negative charge as well as lone pair of electron. therefore they are negatively charged. They interact over here by dipole interaction, and that's why it is stabilized. So the Grignard reagent will be stabilized by ether in this way. Remember and keep in mind, Grignard reagent is used in ethereal solution for synthetic purposes, because if you remove the solvent, then as I have told you before, it is reactive toward water. Therefore, you will not be able to isolate this Grignard reagent and use for synthetic purposes. That's why it must be used in ethereal solution. Now, here two things will affect the rate of formation. One is R and the other is X. Two things are here which will affect the rate of formation or ease of formation of GR, Grignard reagent, ease of formation of Grignard reagent. One is the nature of R in the alkyl halide. R in the alkyl halide, that is the nature. If this R is a bulky group, then the preparation becomes difficult. And if R is simple, or you may say primary alkyl halide, then preparation is easy. So keep in mind, if R is simple, the preparation is simple, the preparation is easy. But if R become branched, then the preparation become difficult. The second part which play a role is the nature of the halogen. You see over here that iodide will react more vigorously and fastly as compared to bromide and chloride. Therefore, the order of reactivity will be alkyl iodide will be more reactive in the preparation of Grignard reagent than alkyl bromide, and this will be more reactive than alkyl chloride. But sometime in exam you will be asked, what is the order of the reactivity? So this is the correct order. Alkyl iodide is more reactive than alkyl bromide and is more reactive than alkyl chloride. But remember, this one is very costly, this one is very vigorously, this one is very slow, and this is the most suitable because its reaction is moderate as well as the cost of this reagent is not too much high. So this is most suitable and this one is more reactive. So keep in mind these two things. Most suitable reagent is alkyl bromide, most reactive reagent is alkyl iodide. Part B of this lecture is reactivity of Grignard reagent. Reactivity of Grignard reagent. Look at the structure of Grignard reagent. Here is magnesium carbon bond. Magnesium carbon bond. This bond between carbon and magnesium is polarized because of the difference in the electronegativity of carbon and magnesium. Carbon is having slight negative charge, magnesium is having slight positive charge. Due to this negative charge on carbon, it acts as carbonyl. Remember, when carbon bears negative charge, it is carbonyl, and when it bears positive charge, it is carbocation. Or this is also known as nucleophile. Carbonyl or nucleophile. Due to the nucleophilic character of this carbon, Grignard reagent mostly undergo two types of reaction. One is nucleophilic substitution reaction. Nucleophilic substitution reaction is this carbon is nucleophile, therefore it may replace another nucleophile. Here this carbon which bears a slight negative charge may attack on electron deficient center in alkyl halide. Here you see This carbon bear positive charge and hence it is electron deficient. Therefore, it may be attacked by this R to give you alkane. As we have already discussed in the synthetic importance of Grignard reagent, you will get alkane and MgX2. Here, this Grignard reagent, it undergo nucleophilic substitution. The second reaction of the Grignard reagent is Nucleophilic Addition reaction. Remember, these are the most important reaction of Grignard reagent. Most important reaction of Grignard reagent. These reactions are mostly taking place between the carbonyl compound. Carbonyl compound means which contain this group. This group is called carbonyl group. These type of reaction, that is nucleophilic addition, they take place between carbonyl compound and Grignard reagent. How? Look over here. Carbon bear slight positive charge again, and this is due to the difference in the electronegativity of oxygen and carbon. Here it is slight negative and slight positive. And again here this nucleophile will attack on this positive center, while this negative will attack on the positive charge on magnesium. And look, this MgX will be attached with this oxygen here like this one, and this R will become attached with this carbon. We will get this type of structure. Remember this structure. It is intermediate and unstable. Intermediate and unstable. Again, I may repeat. R is having negative charge. Magnesium is having partial positive charge due to the difference in the electronegativity. R, because of the negative charge, may attack on the positively charged carbon, and this negative oxygen may attack on this positive magnesium center, and we will get this intermediate. This intermediate may undergo acid hydrolysis. Acid hydrolysis. Here I have taken water and acid medium. So here again this negative of oxygen will attack on the positive charge of water, and this negative will attack on the positive magnesium. Positive magnesium. This negative will attack on positive ion of water, and the negative ion of water will attack on magnesium. And here this H will become attached and we will get alcohol. Remember, this is alcohol. We will get alcohol. And OH will become attached with magnesium and halide. This compound will be named in alphabetic order. If it is chloride, then chlorohydroxide, and so on. Bromohydroxide, and so on. So that is Grignard reagent. Because of the negative charge, it will undergo two types of reaction: nucleophilic substitution and nucleophilic addition. And substitution, it will replace another nucleophile like this one. Here it attacks and replaces this one. Nucleophilic addition will take place at an unsaturated center. Unsaturated center mostly in carbonyl compound, where the carbon oxygen bond is polarized. On positive charge, this negative will attack and this negative oxygen will attack on this one. You will get this intermediate, and this intermediate, as I have told you, is unstable. It will undergo acid hydrolysis and you will get finally alcohol here. Now, coming toward the reactions of Grignard reagent. As we have already discussed, that Grignard reagent is synthetically very important compound. It can be used for the preparation of alcohol. It can be used for the preparation of aldehyde. ये यहाँ पर इधर देखो, यहाँ पर मैं एक तीर से 3 शिकार करूंगा, एक तीर से 3 शिकार. हाँ, look over here again. Here it is negative, it is positive. So this negative will attack over here, and this negative will attack over here. Again, this negative will attack on this one, and this negative will attack on this one. We will get again this intermediate. Look here, MgX become attached over here, and this R become attached over here, R become attached over here. You get this intermediate as we have discussed over here, this intermediate. Now, acid hydrolysis, how it occurs? Here, this negative oxygen will attack on this hydrogen, and this magnesium will be attacked by OH. The reaction is quite similar to this one. It is similar to this one. It is similar to this one, and here you will get primary alcohol. So if you understand only this reaction, then the rest of the reactions, they are exactly the same with only small difference here. R attack on this carbon, Mg is attacked by this oxygen. You get this intermediate. This intermediate on acid hydrolysis give rise to primary alcohol. अब यहाँ पे सिर्फ एक चीज जो है ये मैंने रिप्लेस किया है. H is replaced by methyl group. The rest of the reaction is exactly the same. So I will replace this hydrogen in the next reaction by CH3, only CH3. The rest of the structure is exactly the same. You will get here secondary alcohol. How? Secondary alcohol. This hydrogen, if it becomes CH3, then it will be secondary alcohol. And in the same way here, if we replace this by CH3, then it becomes acetone. And here you will replace the other hydrogen by CH3. So here you will get tertiary alcohol. It is quite simple. There is no ambiguity. So keep in mind, sometime in exam you will be asked how you will prepare primary alcohol, secondary alcohol, and tertiary alcohol from Grignard reagent. How you will prepare them. So keep in mind, Grignard reagent react with formaldehyde to form primary alcohol. Grignard reagent react with acetaldehyde to form secondary alcohol. And Grignard reagent react with acetone to form tertiary alcohol. This topic is very, very important from MCQ point of view, because in some time an exam it will be asked how you will prepare primary alcohol. Yeah, which of the following will react with Grignard reagent to give primary alcohol? So this will be the right choice. And if this react with acetaldehyde, Grignard reagent react with acetaldehyde, then we will get a Grignard reagent. Acetaldehyde will get the secondary alcohol, and acetone react with Grignard reagent will get tertiary alcohol. This is quite simple. Now preparation of aldehyde. Grignard reagent react with ethyl formate. This is ethyl formate, and this is ethyl acetate. Only this reaction should be understood, this one. Keep in mind, if you understand what is the negative center here and what is the positive center here, and what is the positive center in the target compound and what is the negative center in the target compound, then the reaction becomes easy. So here carbon carries positive charge, it will be attacked by this one, and this negative will attack on magnesium. We will get this intermediate. Look at this intermediate, MgX is attached with oxygen and R is attached with carbon. Now again, this compound is unstable, right? This is unstable. It will undergo a rearrangement. How? The lone pair of oxygen will be shifted toward carbon. You will get this aldehyde. You will get this aldehyde. It will be shifted over here and this will be shifted toward magnesium. We will get this compound as well as an aldehyde, right? Now, with ethyl acetate, the reaction is quite simple and is like this one. Just here, replace this by CH3. CH3. Here, you will get CH3. Here, you will get CH3. And the rest of the reaction is the same. So here you will get acetone. So that's why we write preparation of aldehyde and ketone. That is, you can prepare aldehyde if you take ethyl format, and you can prepare ketone if you take ethyl acetate. The reaction is exactly the same, with only difference that H here is replaced by CH3. That's why Grignard reagent can form aldehyde as well as ketone.
Start.
Reaction with carbon dioxide. With carbon dioxide, Grignard reagent form carboxylic acid. Carboxylic acid. How? Again, look over here. R of Grignard reagent will attack on the carbon which carry a slight positive charge, and negative oxygen will attack on the partial positive charge of magnesium. And again, you will get this unstable intermediate. This is intermediate. R become attached with this carbon and this oxygen become attached with magnesium. And then it undergo acid hydrolysis like the previous reaction, acid hydrolysis. And this acid hydrolysis, this negative attack on this hydrogen, and this magnesium is attacked by this OH, with the result that we get carboxylic acid and MgX OH. This is the end of this chapter, the end. Because the rest of the chapter, that is alkyl amines, have been omitted in the condensed syllabus, Board of Intermediate and Secondary Education, Peshawar. This is the end of alkyl halide, and the next chapter which I will teach is aldehyde and ketones.